continue with the example we looked at in the previous video. So we have the cylinder here, and we're given the pressure at 1 and the pressure at 2. We're given the height of the cylinder, its diameter. We're given K equals 0.001 centimeters per second, and we've been asked to find the time for 1 centimeter cubed of water to flow through this system. So, once again, we know that Q equals Ka dH on dl. Okay, so we're going to go find this flow rate Q. So we know K, it's been given. We know A, we can find A easily. A is just the area, so it's going to be pi by diameter, or R squared, is pi by 5 squared. Okay, so pi by 5 squared, we get 78.5 centimeters squared. Okay, we now need to go and find DH and DL. So straight away we know that if we're dealing with head, we're going to have to use a datum. So we're going to we'll just define our datum at the bottom. So there's our datum. So at the point 1, which is up here, we know head is Z1 plus the pore water pressure divided by the unit weight. Okay, the elevation Z1 is 1 meter, so it equals 1 plus the pressure has been given as 20 kilopascals, so it's 20 on 9.81. Okay, so 20 divided 9.81 plus 1 is 3.04 meters. Just once again, I'm being consistent with my units. 20 kPa is the same as a kilonewton per meter squared, and this is in kilonewtons per meter cubed. When we do this, we're going to get back to meters. Okay. The head at 2 equals Z2 plus the pore water pressure on gamma W. So at our point 2, we have 0 elevation, so it equals 0 plus the pressure at 2 is 40 kilopascals, so it's going to be 40 on 9.81. So 40 divided 9.81 is 4.07 meters, which means we can find our change in head, which will take the absolute value, 4.07 minus 3.04. We get an answer of 1.04 meters. Okay, our change in length from point A to B is from point 1 to 2 is simply 1 meter. Once again, I have to keep my units consistent. I'm dealing with meters and meters. I can now find my change on H on change of L, or DH on DL, which is my hydraulic gradient. So the change in H was 1.04 and the change in length was 1 meter, which means my hydraulic gradient will just equal 1.04. Okay, so I found everything I need. I know K, I know A, and I know DH on DL. So let's just quickly sum up that information. So K equaled 0.0001 centimeters per second. My hydraulic gradient I, or DH on DL, equaled 1.04, and that's unitless. And my area equaled 78.5 centimeters squared. Okay, which means I can now work out Q will equal 0.0001 by 1.04 by 78.5, and if I calculate that, I get 0.0082 centimeters cubed per second. Okay, let me just double check that. 0.001 by 1.04 by 78.5. Sorry, this is right. 0.0001 times 1.04 by 78.5. Yep, 0.0082 centimeters cubed per second. Okay, once again, just be consistent with units, centimeters and seconds, centimeters squared, so I'm going to get centimeters cubed per second. So now I want to know the time taken for 1 centimeter cubed to pass through. So it takes 1 second for 0.0082 centimeters cubed per second. So to find how long it's going to take for 1 centimeter cubed, I mean, intuitively it's obviously going to take more than a second. So we're going to take 1, so the time taken will be 1 centimeter cubed divided by 0.0082 centimeters cubed on second. In terms of units, the second will pop up, these centimeter cubed will cancel, and the second will pop up to the top. And we're going to get 1 divide. This answer is 122.49 seconds. Okay, so the time taken for 1 centimeter cubed of water to flow through this soil, so this is filled with soil, the time taken for that will be 122.49 seconds. Alright guys, hope that helps.